what we are trying to do now is to have a look at how QGIS works, especially for what you will need during the next days. We don't have much time to do so. So if you are starting from scratch, you will likely feel that it's not enough, and it is likely like so. But just try to follow my presentation, my demo, and then after half an hour or so, Ricardo will basically repeat everything again, but focusing more in a practical application. So we see what exactly you need to perform the mappings next days. So my suggestion is that if you're starting from scratch, follow along. Don't try to repeat now. You have the possibility to try to repeat everything in QGIS, of course, later using the recorded session, but also when Ricardo will try to summarize what we said. So I've got a very short presentation. If you don't have the data set we are going to use, grab it now, because it's a little bit a large data set. You should be downloading it right now, so you can use it later. And Ricardo will tell you more about the geology. And well, one important point to understand is that typically, historically, geological maps were being doing on paper, right? So there were people drawing contacts, drawing geological units straight on paper. And then the final product, you ended up with something like this. So a geological map of an area. And what other users could obtain was exactly this kind of product. So just the geological map. There were no intermediary products that could be shared. And so anybody wanting to, let's say, improve the same map for an area had to start again from scratch, basically. Now, what we're doing now is that working in the digital realm using computers makes everything more flexible. So one thing to keep in mind is that now we have intermediary products that can be shared with other scientists, with other researchers. And those are what are here called GIS files. So files collecting basically the mapping work you've been doing. And from those files, yes, you can obtain a printed map, but it's just one of the many products you can use those GIS files for. And in particular, now we can reuse the data. Reuse means improving the map in the future. You have new mission, new instruments on board a new spacecraft, you get more data, you can improve your map. And people can reuse the data. So one thing to keep in mind when you do your mapping, do not consider just the final aim, that is create a beautiful with colorful map. But keep in mind the data you are preparing might be something that will be used again in a different context. And caring about the integrity of the data you are creating, the correctness of the data you are creating is something important now. As Alessandro was mentioning, there are many different GIS systems. Some are commercial. You might know ArcGIS, for example, but there are several open source. We are using QGIS. I believe most of the people know it as QGIS, but it will be actually called Quantum GIS. And one big point I want to make is that keep in mind the difference between two different representation models for the data we're going to use. And one is vector data on one side, and on the other side, we have raster data. That's the only point I want to make now, just very quickly and simply. Vector data is represented through using vertices. So you basically compose a list of vertices in your program, normally by point and clicking, right? So you click one point after another, and you store the coordinates, the geographic coordinates of each of those points. And then you can arrange the points in different let's say, configuration. If you connect 2 points, you get a segment of a line in between them. And if you do that multiple times, you can trace lines. And of course, if you arrange them properly, you can list a series of points forming a line that outlines a polygon. So you have those different layers of, let's say, representing data, which are point data, line data, and polygonal data. Let's say in the raster way of representing data, it is a little bit different. And you are, of course, familiar with raster data because they basically are images. So when you look at a color image like this one, for example, and you zoom in, you can spot the fact that it's actually composed by single pixels. So raster data are just a matrix of pixel, and for each of the cell of this matrix, you just have a value, which can be either a real value, so I don't know, 2.5, 6.6, something like that, or an integer values for some specific representation. So for example, if you want to represent, like in the central image here, 3-4 different classes of land use, like in this case, you can encode that information into 4 or 5 integers, like 0 for one class, 1 for another, 2, etc., and then use that values to let's say codify the information you got about an area into a raster. And the same, you can do the same basically for anything. So if you want to store topography, elevation, you can store the elevation as a real value within the cells of your matrix. And this, of course, works for RGB products, let's say color images. You just store 3 different layers, 3 different bands. Normally, they are normally called bands. One for the R for red, one for green, and one for blue. And then putting them together, all the 3 layers, you can actually have color images. Again, vector data is a totally different representation of geographic features. You start from points, and for example, you might use points to represent something that at the scale of your mapping makes sense to be represented as a point, because there is not entity that has no dimension, of course, in reality, but most of the time it makes sense depending on the scale of your mapping. And then you have lines and polygons. You basically create organizing the vertices or the points in the correct way. What we're going to do with MAPI, that's the plugin we're going to use to simplify geological mapping, is nothing really, I would say, special, but speeds up a little bit the process of creating your geological maps. And the idea is that we will be tracing lines onto the map, like in this first image. And then we will use some points to label each area that is delimited by the lines in a proper way to represent, in this case, 4 different geological units. And then using those 2 layers, those 2 information, we create polygons at the very end to generate a proper geological map. That's the key idea. This is a more realistic example. The one Ricardo will go through later. And I would like to try to jump in and open QGIS. I left here a couple of information if you need. But okay, so I will start QGIS. Ricardo, do you have any comment before we start?
Okay.
Okay, thank you. Okay, so this is the main interface of QGIS. You can start it if you, of course, installed it. You can start it from your, I guess, from your desktop or wherever you keep your programs, depending on the operating system. And the main components of this software, let me try to move the You cannot see it, but I got the zoom toolbar in the middle. Can you still see my screen, Ricardo?
Yes, perfectly.
Yeah, okay, good, thank you. So on top, you have a menu. The menu I'm referring to is the one with the words, let's say, so project, edit, view, etc. I keep it in English. It might be possible that in your case, it got automatically localized. So if you do a quick Google search how to localize properly QGIS, you can find how to change it if you really want to, or you can also keep it in your own language. Anyway, so the top bar is called the menu, where we can access basically everything. So everything you can access from other places, most of the time is also present in the menu. It's just a matter of finding it where it is located. It might be a little bit difficult. At the bottom of the menu, we have a series of toolbars. So each of those horizontal collection of buttons is called a toolbar. So here we have 3. Now, we also have panels, which you can actually move them around, put them together, and etc. So those are this one, which is called browser, or this one called layers, panels. And in the very middle of the software, you have a canvas. The map will be placed basically here. Now, as just opening you have just a couple of dialogues with news and project templates, etc., in the rest of those projects. Okay, so this is about, let's say, the language we need to know to understand each other. One thing I would like to do is go through the project that Ricardo prepared. When you download it, it's a zip package containing this Moon Final Release 2025 dataset. Within the dataset, you can find 2 folders, one for raster data and the other one for vector data. And I would like very quickly to show you how to load data in a QGIS project, which is extremely simple. One way to do that is just to grab and move the file you are interested in into the project. I will show that. Or, for example, we can use this EM. I just get it and move into the project. So just moving into QGIS, 2 things happen. The first one is that the layer get loaded and is now visible in the layers panel. And you can, of course, enable, disable, do whatever you want. We will see better later what we can do. And the second thing, important thing that happened is that QGIS didn't know how, what CRS or what reference system to use for this project at the very beginning. When we imported the first data, it set the project CRS to match the one of the data we just imported. So what this means is that I forgot one bar, that is the status bar at the bottom, this one, where you can see coordinate scale, etc., etc. But the very right, you can see here current CRS equirectangular moon. And that got imported straight from the data we loaded as a first layer. Of course, later you can import more data. So, for example, I will try to bring in this another raster, or you can, of course,
Luca,
yeah, sure.
If you want, you double click on the data on the left, you can see the embedded coordinate reference system in the data.
Of course, of course. There are many information we are getting there. Basic information can be found here. So, for example, by double clicking on the layer, you get a lot of options, and with information where the data comes from on your disk, let's say, symbology to use to represent the data, etc., etc., and also information, the coordinate reference system that is attached to that specific data set. A completely different thing, not really completely, but a different thing is the CRS we use for the project. You see here, it's called Project Properties, Project Coordinate Reference System. And let's make everything simple. Let's believe me, the CRS that got set up when importing the first data is the correct one, but normally people would spend a lot of time to figure out exactly how the projection should be set up and how to possibly reproject all the data if it is really needed, for example, etc., etc. But for our case, let's say everything got in the right order. So you can load, for example, vector data, and you see here there are already several features, several layers in that file. I just drag and dropped in QGIS. I will just add them. There is just an example of a map that is not really, well, it's not really important for us, but it's just to show something. And I believe that's all on importing the data. And what I want to show you is, so basically just try to imagine that QGIS works as a image editing software, something like that. You might be more familiar. You have the different layers. You can stack the layers in different ways. You can even group the layers. You can do some keep some order. When you start having, I don't know, 100 layers, you really need to keep them in a nice fashion. And you can enable, disable them, and they will show up depending on the order that you can find them into the layers window here, the layers panel. Next thing, I would like to show you that you can query data. So for example, in the main toolbar, this one, which is called the attribute toolbar, there's a button with the identify features. You can also use the shortcut Ctrl+Shift+I. And if you click that, and then, of course, you select the layer you want to query. So, for example, if I select this raster, I can query a specific pixel. You see, this is a specific pixel of that raster, and I get some information here. I'll close this one, some information, also this one, some information here about the bands value for that raster. So this is telling me that it's a multi-band layer with 3 bands, red, green, and blue. And those are the values encoded for that specific pixel. So you can query your map in this way. You can basically do the same for vector layers. If we consider this polygon, we can click on the polygon and I'm getting some information out of it. And in
Luca?
this case, yeah, sure.
Can you go a little bit slower?
Even slower, okay. We don't have much time. I will try to
Thanks.
do so. I will try. Okay, just quickly again, we can use this button that is called Identify Features in the top toolbar. The toolbar I'm talking about is called Attributes toolbar. And we can use it to actually identify properties of the underlying layers. So for example, if I select, let's try with the DM, for example, I select the layer and then I click on any part I could be interested in, the corresponding pixel gets selected and I can find information in this panel that is called Identify Results. You can do the same if you select, for example, a vector layer, like in the case of this polygon. If I select this polygon, I get some basic information out of it. And this will be needed later when we need to actually edit the information that is connected to each points, lines, or polygons. Okay, very quickly, just because I know I'm going fast, I will do it again. So you basically can drag and drop any file. QGIS will understand a lot of different file formats, and we'll just cope with them by loading them as layers. the same is true for vector data. Of course, in this case, you have multiple layers within the same file. So he's asking me whether I want to load all of them or just a subset. And you can load them like so. Okay. Now, again on layers, you can arrange them in this layers panel by creating groups. For example, if you click on this little icon here that is called Add Group in the layers panel, that it is the second icon from the left. You can create groups. It works, as I say, basically like any image editing software you may know. You drag and drop layers in groups. That makes quite easier to enable and disable them quickly, or also to just keep some order in your data, like so. Maybe you want to. I was just showcasing how to rename the layer, but I realized if I don't tell you, you can press F2, for example. That will enable you for renaming the layer name or the group. And then, of course, if you right-click with your mouse, you can, of course, rename here a group. So for example, I create a group for raster files, one group for vector files, and so on. And okay, some basic operations you might want to know how to do. So right-clicking, of course, opens the context menu in most, basically in any part of QGIS. So if you want to find out how to do something on an object, most of the times by right-clicking, you can find the correct entry in this menu. If you double-click on one layer, you open up this window that basically collect all the information that are related to this specific layer. We see that the information are a little bit different depending if it's a raster layer, for example, which they do have a specific way of being represented. And of course, if it is a vector layer, it is a little bit different. Again, you have a symbology you can use, etc. Okay, some basic operation with the mouse. So to zoom in and zoom out, I already showed to you I was doing that without telling you how. To zoom in and out, you can use the wheel on your mouse. So if you don't have a mouse and you are working on a laptop, better to go get one if you have one lying around. But if you don't have, you can still work with let's say, with a laptop, with a mouse and keyboard. Zoom in, zoom out with the wheel, move around by pressing on the wheel. So you press on the wheel and you can move around. So basically, to navigate your canvas, you basically just use the central button, or let's say the wheel. So you zoom in, you zoom out, and you move around. That are all you really need for that. Right mouse button, left mouse button are of course used. The right mouse button open also in this case a context menu that it gives you the opportunity to identify exactly what we did before. It identifies specific pixel in this case. And right-clicking does nothing in this moment, but you will see how we will use right and left clicking to create lines and points and polygons. Okay, so normally after you have been loading all your files and you are happy with them, the next time you want to skip this part and you want your project to be saved somewhere. So one will typically go over on project on the top menu. So project, save as, save or surveys, save. Well, they basically are the same in this case because we never saved the project. So if I press save, it gives me the opportunity to save the project as a QGIS project format. And I can just save my project. Next time I load that, I will start again exactly from this configuration. Any customization will be saved in the project, so you don't lose anything you have been doing. And the last thing, I would like to go back a little for a moment in the data folder Ricardo put together, and I want to show you that this file, the Moon GMAP Winter School 2025 QGZ, is actually the project file. And one thing I want you to notice is that the file is quite small. Basically, is this just a text file describing the configuration of QGIS when it was saved? It doesn't contain any raster data, any vector data. They still need to be stored in dedicated folders. And to avoid creating issues when you move your project around, the best practice is to create a top-level folder where you store inside both the project and any additional data that goes with it. Because the point is that if you move just the project around, I send this project to you, you try to open it, but you will try to locate both raster and vector data that were used to create that project. And if QGIS cannot find them, you will be basically without data. And so best practice, keep just one, let's say, root folder where you create your project, and you also store any data set that is needed for your project. So whenever you have to send your project to someone, you just zip it in just one archive, everything, and you send it as an entire folder. Back to QGIS. I closed it. I don't know why, but let me open the project now. And you see that everything gets organized as Ricardo saved it the last time. And you have the entire data set that you need to start creating your map. So the last thing, one of the last things I would like to show you is that QGIS features a lot of plugins. So, for example, we are going to use this Mappy plugin. If you, as I guess you don't have it installed, I can show you how to do so. You basically go on in the top menu, under plugins, manage and install plugins. And you can find a long list of plugins. You can install them. You could install any of them. And to be sure to also be able to find Mappy. So if I write here Mappy, you see I've already got it installed, but if you don't, you must remember to go under settings and tick this box that say show also experimental plugins. Just enable that option, so also Mappy gets displayed. Now you look for Mappy, and here you have an install experimental plugin. You can just install it. There are plenty of QGIS plugins for doing a lot of different stuff. The reference page is plugins.qgis.org. And of course, you can navigate all the plugins that do exist. If you order them, for example, for the numbers of downloads, you can find some very popular plugins to provide base maps, mostly for the Earth, basically. But some tools that are very useful for us, like the profile tool, etc. For example, also Mappy has a page here, so you can look for Mappy. You can find a page where there are some information and links to the documentation and where the development happens. So again, plugins, manage and install plugins. Be sure to, under the settings tab, to have shown also experimental plugins enabled. And under all, you just write Mappy. You can find Mappy and install from top right button, the yellow one, let's say install. experimental plugin. You can install it. Okay, so let's jump very quickly into editing vector layers. That is what we really need to create maps. And I show you the basic idea behind mapping, and then Ricardo will be back again on this with some more advanced features, some more advanced, let's say, advanced editing tips for you, and also will show you, demonstrate you something more realistic. So the idea, as I said, is that we just trace lines. So to edit a layer within QGIS, you first need to enable it for editing. To enable it for editing, you can either select with the left click the layers you are interested in. And then in the context menu, you can find toggle editing. Of course, there is a button in the toolbar, which is this one. You can just press this one, and the layer, you see a little pencil, yellow pencil appear, and the layer will be enabled for editing. So you can enable or disable. This applies for vector layers only. You cannot really edit in the same way raster layers, of course, because it's a totally different representation of the data. The idea is that we select the linear features layers that is already prepared for you. We toggle editing, and then to trace a new line, because in this case we are talking about lines, we need to select the proper button in the toolbar, which is called Add Line Features, which is this one. It's basically the next button at the right of the toggle editing that is active. So it's Add Line Feature. And of course, you can use also Control and dot on your keyboard as a shortcut. So you click on that, and now you see that the pointer becomes this cross, how is it called, cross whatever. This little cross you can use to trace lines. To do so, you basically use your mouse and do left clicks operation to trace a line. So for example, I'm trying to trace around the rim of the crater, something like this. When I'm happy with a line, in this case, keep in mind I'm trying to close the line, so cross each line in this way. And when I'm happy, I can do the last click I want, and then by right-clicking, I'm closing the line. So I'm stopping editing that line. So right-click, this opens an edit dialog that gives me some option. So those are information that will be stored together with that line and will be preserved for that specific line. So as an example, we already prepared for you two fields like the certainty and the type. So for example, certainty can be used to say whether and how much you are certain about a contact, like in this case. In this case, I'm quite certain about that. And about the type.
And
sure.
Interject 1 second. Here you are using the linear features. You will see that we have 3 different vector files: linear, source, contact, and source indicators. So in this case, this would be used for linear elements like poles, whereas the source contacts needs to be used for the polygons. They are interchangeable, but the fields are different. So in this case, it's like a fault. So it's a normal fault encompassing the crater, the type.
Yeah, indeed, Ricardo, I started editing the wrong layer. That's not
No, but it's okay.
Yeah,
it's okay.
okay.
Just to
yeah.
to make it clear that we have 2 layers that we can edit. And,
yeah, indeed. We have two different layers. One is linear features. We just prepared those 2, but normally in the everyday practice,
you can have whatever.
You can have whatever. You can create any number of layers you really like. And the linear feature one was thought to be to contain, let's say, faults, fractures, anything that is linear, and you can represent with just a line. and is not needed to, let's say, create the polygonal layer of your map. So, for example, I might be, let me go back again so I can showcase.
In this
it
case, it's anyways correct because you are encompassing a scar, which is
Yeah, of
a
course.
normal fault. So it's totally okay.
Yeah. Let's say I will trace a little bit better, this case, just this portion of the scarp, and maybe I can say I'm certain, and I can say here a type, I may want to call it scarp. This is needed because later you can style the appearance of your map depending on these properties. So when you create the final map and you want to create a beautiful legend that say this style is for all the scarps, this style is for the fractures or for the folds or whatever, you need to store a little bit of information and do that while you do the mapping, because if you trace hundreds of lines at the very end, it's very difficult to go back to each of them and have a look at them again and maybe assign how much you were certain, how much, what exactly the type was, etc. Anyway, this is an example. And when you're okay with editing, you just disable editing, and QGIS see that you haven't saved the changes for the layers, so you can save the changes. And that will make a permanent line within the linear features. So now we will be using mostly this layer, the source contacts, and the source indicator layer. I will show you now how they works and what is the idea behind. I will disable the linear feature one. So I select source contacts. I toggle editing. You can do it again, right click, toggle editing, or via the toolbar, toggle editing. Now to add a new line, I will just use the add line feature, that is the button at the right of the toggle editing. I enable it. And now, for example, I can trace very quickly the entire scarp all around. I can close. So left clicking to put down points, vertices of the line. So here I need another point just to cross the start of the line. And to close the editing, so to stop editing that line, right click on your mouse. So right click. This will bring up this dialog. Again, you have just one field in this case. I might say I'm certain. I mean, the entries you put in here are something you can figure out by yourself. It really depends on the strategy used for mapping, how much, let's say, fine-grained you want the classification to be for your lines. So now we do have a line. Let's say I create another line to represent the central, I would call it the carbon central floor. Is it right? Let's say the floor of the crater. And also this time I will cross the two lines and then quite certain, and one for the, let's say, this big.
Anyways, for all the participants, don't worry, just try to follow because I will redo everything from scratch.
Ricardo will be
Creation of
doing
the
it
project and the map.
Okay, so I traced some of the elements I would like to put in my map. And now what we can do is use mapping to make the polygons. And it's quite easy. There is this map dialog. You just need to be sure you configure it accordingly to what you really want to do. So you have to set up the limits layers to match the line layers we need to use to create the map. You need to set up the indicator points to match these layers, so source contacts, source indicators. Just be sure we call them source because are the two that are really needed to create your map. Then there are other options like unit name, that is a field of the source indicators. You will see what I mean in a moment. And then you can basically output the geopackager wherever you want. You will probably want to output within your main folder. So maybe vector, you say geomap, that's fine there. And you can also customize some option here. That's not really important at the moment, but the only thing you have to do is press this recompute map and obviously save everything if it's needed. And what you are getting as output is a final map layer, this one, which is made up of polygons. I will show you. So for example, again, we use the identify features button in the top toolbar, and you can click on all the different polygons. So each polygons became an independent, let's say each area defined by the source contacts became an independent polygon, right? So you can click on them, and of course you have the information about the polygon here. So for example, you see that unit name field for each of those polygons is set to null. So what we really need to solve here is giving a name to each of those units. So to do so, we use the source indicators layers, which I am moving a little bit up, just to be on top of the polygons. So you see that Mappy created already for you 1, 2, 3, 4 different points that are located, let's say, in a kind of, let's say, a center of each polygon. And we just need to set a name for each of those points to have the final map to have propagated the name of the different units. So I select the source indicators, I toggle editing as we did before, and then you can use the identify features, for example, to click on a point. And you see here what we want to do is set the unit name. And under identify results, you see you have different utilities. The first one is edit future form. By clicking that, this opens up the form. And now here I can set the name of the unit. So this unit will be the floor of the cutter, and I press OK. Next one, this one will be basically the rim. Press OK. Next one, it's central pick. Just try to be consistent with the names you are giving them. And that's fine. Whenever I'm happy, I can also save it by hand. So next to the toggle editing button, you can find the save layer settings. You can save it. And by just clicking the recompute map button of the Mappy plugin, now you see we got colors out of the map. So we got correctly labeled polygons for the central peak, for the floor of the cutter, and the rim of the cutter. So that's the idea. I would avoid to go more in deep with that, right, Riccardo? Because well, the time is what it is.
Okay.
Do you see there is anything? The last thing I would like to show you, maybe, but you can also show it later, Riccardo, is the processing toolbox. Do we want to install the symbology, right?
I can do it from scratch. Now I will open an empty project, and I will show you from scratch how to set it up.
Okay, great.
The plugins and everything.
You can do that. That's great.
Yeah.
And yeah, I really hope the main things get through some way. I know it's difficult, but